We're back from our commercials. In my panic state, worrying terribly that you all may not be able to complete this wonderful lab, which teaches you all these wonderful techniques I'm sure you're very eager to learn, I panicked and forgot the golden rules of when in doubt, search ArcGIS help on the internet. So I'm just going to search ArcGIS 10 raster calculator because that's what I need to find. Oh, the new and improved raster calculator. Ooh, Esri has a blog. I'm gonna have to put this one on my RSS feed. Great, it's new, it's improved, and it still exists in ArcGIS 10, so that's good news. It means we can still do this lab. Now I need to find it. To do that, I'm going to use the other golden rule of this wonderful search bar here. I'm going to type in raster calculator, spatial analyst. Wonderful. Let's see what this gives me. Bam! Raster calculator. Looks like a calculator. Has rasters on the left, right? Those are the rasters that I have in here. Uke distance fin, PC lobe raster, hill shade, DEM. Cool stuff. So what the raster calculator does is it does math on rasters. Let's say we took our PanumCrater DEM, right? Let's display that just to think about this. Let's say we take that DEM and we just said times 2. What that would do is it would take each pixel value here, right? You can see all these individual pixel values, and it would multiply that pixel value times 2. That would effectively make our elevation range something like 4,700 to about, let's see if I can do math. No, thank you. About, oh man, 3,900. Jeez. Okay, so we proved that I remember how to multiply. The other thing we can do is we can do math on multiple rasters, right? So we could take, say, our DEM, and we could multiply it by our Euclidean distance. I don't know what that exactly would tell us, right? But that would take this pixel value for the Euclidean distance and multiply it by the raster. Now that would give us some range of 0, right? Because we have some pixels that are going to be 0 to whatever the greatest elevation times the greatest extent is. Now, because we're multiplying things that have a spatial extent associated with them, the raster values that go up to the highest number here are not necessarily coincident with the highest raster values here. So the highest raster value that we might get by multiplying these two things together is not necessarily the highest value of this raster times the highest value of this raster, right? That's just because we're taking each pixel value, multiplying it by another pixel value. If you take one raster that has a larger pixel value than another and multiply them together, Arc will sort of average the pixel values of the smaller pixel extent raster over an area that coincides with one of the area represented by one of the larger pixel values, and multiply that average value by the regular value, ultimately reducing the resolution of what you come out with. That's why we defined all our rasters as having the same resolution, which was the resolution of our DEM, 10 meters. That's just a nice round number. That's not what we're going to want to do right now. What we're going to want to do is we want to get this distance thing to be only within our lobe that we've mapped, right? We don't want to calculate potential velocities of volcanic ejected material out across the lake. People just wouldn't believe we were sane if we did that. So let's go and let's multiply PCDEM. No, not that. Let's multiply our Uke distance fin. So Uke distance fin times PC lobe raster. Now you notice when I do this, I'm always clicking things. That's because this sort of command box, while you can type stuff in it, does not like spaces. It's very sensitive to how you put in names. It's case sensitive. It's quotation mark sensitive. It's emotionally sensitive. Just click the buttons. It likes to be touched. Um, let's not save this in the default location. Let's save it in our home folder here. Let's call this PC lobe dist. Now, why I'm multiplying these two things together is because my values of 1, right, aren't going to change this distance raster, but my values everywhere else will change that raster. If maybe you had a PC lobe raster value that was 0, you could do PC lobe raster plus 1, which would give the lobe a value of 1 everywhere, and then you could take that and multiply that times your Euclidean distance thing. Okie doke. PC lobe distance. Save. Let's see what happens here. Raster calculator. Bam, look at that. We have made ourselves a smaller raster, right? It has values from 190 to 1857. Those seem reasonable given what these things are. Let's just double check that. Let's turn our Euclidean distance test back on. Let's find our measure tool. Let's sort of see what our values range from. Looks like that one's the biggest one. It's about 1850 something. That seems good. And down here, something like 197 is the smallest that I see. Great. Seems like that worked all right. So let's go ahead and stop there and come back in just a second.